Hi guys, this is Kurt, Oscar, November 7, Oscar, Foxtrot, Foxtrot. In today's video, I'm going to explain you how you can control your beam from within the Thetis software. So by the end of this video, you will know how to integrate your beam system into the Thetis software without having to use the front-end software of PST Rotator. A side note, you will need to have PST Rotator as your controlling software because it's the only one, as far as I know, that can be integrated into the Thetis software. So without further ado, let's just dive into it. So we're back. In this video, we will have three parts. The first part, we will talk about integrating PST Rotator into your Thetis software. So you can control the headings, you can see your headings using this little applet that you see right here. The second part of this video is going to talk about how you can integrate not only this section here where you can see your rotator headings, but also you can use the Cluster-TCI-Bridge to visualize your beam headings on the world map in the background of your panadapter. And then the third part of this video, we're going to explain you how you can easily integrate the personalized map into this little applet over here, because every QTH is different and you might need to generate your own map. Let us first start with the configuration of PST Rotator itself. Go to Setup and just be sure that UDP control is enabled. So there should be a little flag in front of it. The next thing you will need to do is go to Communication and then go to UDP control setup. Be sure that the exact configuration is done on your PST rotators. So the port number should be 12,000. The IP address is your local IP address. And the automatically position reporting when the rotor is moving should be enabled as well. Once you've done that, you're about to go ahead and do the configuration within the Thetis software. Now that we have started the Thetis program, go to Setup here, and then go to Setup again. And then you will need to go to Serial, Network, and MIDI-CAT. Choose multimeter IO. Now, before I fill in the information here, let me just bring up a little schematic I have made for you guys. So this is the PST rotator right here. And you can see that the receive UTP data port is 12,000. That's what we have defined in PST rotator. In the manual of PST rotator, the transmit port of data, UDP data, will be one port higher. When PST rotator is going to transmit data, it's just to tell what are my current beam headings. And this will be on the receive side of Thetis. If we need to change the beam headings, we will need to transmit this UDP data back into PST rotator. So it will be port number 12,000. Click here on Add UDP. This is where you have to listen to the data. So this is when I bring back the schematic. This is where we will listen, and it's going to be port 12,001. So here I will need to define 12001. So this will be the receive port. Now we will have to do both. So currently we only have the direction in defined. So we go to both. And we are going to also put the data format in raw data as far as receive and transmit is concerned. And we will need to define also the port number for the transmit of the data. So basically we are in this here in the schematic, transmit data, that will be number 12,000. And here I will change the port number from 10,000 to 12,000. And normally we should be good to go. So how do you know if it's work or not? Just turn your beam on your rotator controller and you will see some data starting to flow And you can even see what is the current headings in degrees right here. Automatically, when you do so, you will also create a 4-character ID. Click this one, so copy on this button so we have it in memory because we will need it right away. Then click on OK or apply and OK. And then we have to create a TRX box. So in Thetis, go to Setup. I will need to go to Appearance and Multimeter or Gadgets, whatever it's named in the newer version. I'm going to create a new TRX box. It's right here, so I'm going to drag it right here so you can see what's happening. And then the next thing you need to do is search for a rotator. So double click it and then click here. And here we need to configure everything from scratch. I already have my map here, but I will explain this in the third part of this video on how to create this map. The arrow is white, so you can barely see it on my white map background. So I'm going to change it to black. And I will also show the bandwidth. And I will change the color here. And I will only need azimuth. I do not need the elevation. And I also want the controls. Now, nothing is happening yet because we need to define the character ID that should be linked to this rotator here or this map here. So click on this percentage and you will see exactly the same character ID we have seen in multimeter IO. Select it. Now you will see that your meter will move to the right direction. And also in the allow control, you will need to paste the 4-character ID over here that we have copied before. And once you apply it, you are now good to go and you can start to control your rotor. Now, if I click, for example, a little bit higher, you will see this green arrow here, allow control. I will change it into, let's say, yellow. So you can see it changes the color. And now you can control your rotator just by double clicking on the map. So that's it. This is how you can configure the PST rotator within Thetis. I'm just gonna explain one more thing. If you disable the, I'm gonna do auto height and I'm disabling the borders and I do not want these controls. Now, if I hover over it, I cannot control it, but if I push on the shift and I go from my mouse from outside the box, I can still control the box. And if I hover from outside the box and then go into that corner here at the bottom, I can also change the size of the box. Now I'm going to also change the size right here. So it's going to fill up completely. I need to have 1, I think, because it's 1/1. Let's now go into scenario number 2. Okay, so let us now combine the PST rotator with Cluster-TCI-Bridge so you can also see your headings on your panadapter using the Cluster-TCI-Bridge rendering software. Now, let me explain you something with a schematic. These TCP ports, they can handle multiple connections, but if you're talking about a UDP port, this is 1-to-1 connection, and you can have only one connected at the same time. We need to read the data of the current headings of our beam, as well as in Cluster-TCI-Bridge, but also in Thetis. So basically there is a workaround. First, we will connect the Cluster-TCI-Bridge to the receive UTP data of 12,000. So I put these UDP ports in red, so it's very clear. And within the Cluster-TCI-Bridge, you have what we call a redirect or pass-through UTP data system. So it's going to get this data and transmit it again to a new port. And what we receive is going to be what we need to receive coming out of Cluster-TCI-Bridge. And this is what we need to receive in our Thetis software. So keep in mind, when we define the receive UDP data, it's not going to be 12,001, but it's going to be 12,100. And the return, so if we want to turn our beam, we're fully going to control the beam within the Thetis software. So basically, we're going to ditch the capability of turning the beam using the Cluster-TCI-Bridge, because that's also possible. But as we do not have this pass-through system yet, as the time of making this video in Cluster-TCI-Bridge, I am going to only enable the beam control from Thetis into the PST rotator using port 12,000. So the practical point, how do we configure this? And we are already in the PST rotator tabulator. And we have defined our port that we will receive the information from. So what's being transmitted by the PST rotator, which is obviously 12,001. And we will also enable a pass-through redirect UDP port, which will be 12,100. Here you can define the beam width, which is currently at 30 degrees. I'm going to increase it a little bit because I only have a 2-element quad antenna, so the beam width is quite wide. And we are not going to enable PST rotator, because if we do so, it will make a connection to the port 12,000, and then Thetis will not be able to send data to the PST rotator software. So this needs to be disabled. Maybe in the future, Ernst is going to add also a pass-through for the PST rotator send feature. And that's it. So we click on save. And now let's go into the Thetis software again. So we are back. Let's go into setup again. And obviously we will need to go to serial network and MIDI-CAT, going to multimeter IO. And here we will have to define all these ports. So remember that this time we do not need to define 12,001, but we will need to define the pass-through UDP port that was defined in Cluster-TCI-Bridge, port number 12,100. I click on OK here. And the next thing we need to do is do the rest of the configuration like we have done before. We also want to control the rotor. So what we need to do is define the rotor UDP port. And this is going to be number port 12,000. And we need to change the format into raw. And we'll just have to turn one time with the rotor. It is required. And you can see the data is coming through. So that's perfect. Click on apply and on OK. Or you can just straight go into appearance and then go into multimeters or gadgets, whatever it's called in the future. Click on add TRX box. Let me bring this TRX box back again over here. And then we select from the list here again, rotator, and we will do the configuration again. So this time the 4-character number will be different. It's this one here. I forgot to click on here to copy this 4-character ID. So I just go back and click on it, go to appearance again. And let's just select it right here. That's done. I want to have my arrow in black. And I want to have also Azimuth only control. And the next thing is allow the control and paste this ID over here. Just make sure it's the same. You can change the colors, whatever you want to your liking. And then you should normally be able to control everything. And if I look here, you can see that indeed I got my, there you go. If I click on it, I see that my rotor is turning. Let me just go back to the controls. I'm going to disable the container control, disable the border. I don't need it. And I will put this at 1 again. So it's going to fill my entire TRX box right here. I need to click on shift and hover over it. And I will also do auto height. I click on shift again, come from the top, go to the bottom left corner so I can modify the size, and we are finished. Normally, if everything should be okay, and if you look at your configuration here, And if you've done everything correctly in Cluster-TCI-Bridge, please refer to my previous video on how to configure Cluster-TCI-Bridge because it's important. You should be able to see your beam headings right here. This is my beam headings. If I would turn my beam, let's say to the southeast, this will be refreshed every 30 seconds. And you will see in a few seconds from here that my headings have been changed on my panadapter map. And now we have a full dynamic map. I will put this one back in this corner here. Now let's go into how can you personalize your map. We first have to create a azimuthal map, so I can do it through two ways. So you can either go and search on internet for create azimuth map. You can see it right here, and select the website of November Sierra 6 Tango. You click on here, and we're going to disable all these. I need to have a blue background, and I want this for PST Rotator, but we'll integrate it later into our TRX box. So you create on create map, and it will download it. It will be downloaded as a PDF file. So obviously we will need to create this as an image. And the next thing you can do is just open it. I click on Start, Snipping Tool, click on New, and try to make a 1/1 ratio. So just like this, you just click on Save, and it's going to save it. It should be named Rotator _map -BG. So once you give it this name, you need to find that file in your, and then you will need to find this file on your computer and put it in a specific folder. But before we do so, there's a second way to have a more beautiful map, in my opinion. I am using Aziworld. So if you search in your browser for Aziworld, you can download this application. Let me bring it up just for the completeness of this video. So I'm starting Aziworld, File, and then back to Map Generator. Click on the location. Let's say I'm in Thailand and I'm here. So I click on it, and it will create a azimuth map for me with the central of the world in my QTH in Thailand. Now let me just bring this here. And then you can use the snipping and make a complete copy and then save it. Once you have save it under the name Rotator _map -BG for background. Open your file browser. So I'll just open it right here. And I will go into the address bar, type the %sign, app data, %sign, then search for OpenSDR. It's right here. And normally there should be a subfolder called meters. In case there is no subfolder, create it. It's called meters with a M in caps letters. And drop that file here under the name Rotator _map -bravogolf.jpg. So Juliet Papa Golf. And then next time you restart your Thetis, it should display the map right here. And that's it. That's the video. I hope it is useful. Give me a thumbs up, give me a like, and also subscribe to the channel. I'm doing this just for you guys to help you out. 70 trees, and hopefully see you on the air. ON7 OFF signing off.